Hello everyone. So one more exercise on fit is I really want to add here. So let's get started. So this is scattered lines outwards, outwards from the origin. That means these are the lines which are scattered round, connecting the scattered points to the origin. Okay. So what we'll be needing? We'll be needing 2 points. Like one of the points will be origin, and the other points will be scattered around the origin in the form of the circle in the form of the sphere. Okay. So let's take the origin first. So that will be int origin, because that is a number. Okay, so that will be add point and just hard code it 0 comma curly bracket and 0 comma 0 comma 0, right? And this will be on detail. All right, so now we have to scatter point around this point. So that will be some user value for num count and num points. So that will be int and num points. Let's take count equals to chi and num points. All right, okay, so let's give 10 points or 30 points, and now we have to go for the for loop. So for int I equals to 0, I less than count and I plus plus. Okay, so that will be vector pos equals to, we will write down all the values, or we can maybe increase in the form of the different floats, but we will take all of them here. So that is set, and then we'll give random values for x, y, and z. So that is rand I. We'll keep it simple first, and then rand I, and then rand I. Okay, and then so this is the pos value, and now we will add points. Okay, so add point 0 comma pos, control enter. All right, so they are coming here because the seed value of rand is same. So we'll add I, let's make it I plus 1. You can take any value, or I plus 2. All right, so now they are, but the problem is that they are scattered in one quadrant like this. Okay, to fix this value, just make the position vector, multiply this by 2, 2.0, 2, and subtract 1. Okay, and subtract 1. Okay, so now that is there. All right, Okay, and now what we have to do, we have to, because this is coming like in the form of, let's make it 300, as it is coming in the form of like scatter is coming in the form of rectangle. So we will normalize for that, normalize the position value. Okay, so we'll again take pos equals to normalize, normalize, normalize pos. Okay, so that will convert all of them into unit value. Okay, so that is why that is giving unit radius, and now we can multiply this value by the fit function. Okay, by the fit function to give them different values. Okay, so let's do that. So we'll again take fit, we'll take fit, and then fit, and then rend I plus 1, I plus any value, maybe 1 2 3. Okay, so that is the value, and comma 0 1 comma, this was old minimum and old maximum, and now new minimum and new maximum. So new minimum is 1 and new maximum is 2. Okay, so multiply. All right, so now they are scattered at different radii, different radius value. Okay, we can give this 0.5 or something. All right, okay, so they are like this. Okay, so now that is add point and that is pos. So we will put this value into another variable, and that will again be int. So that is int scattered points, scattered points, scattered points, and now we have to add them through polyline. So for that we will use add prim, and it will take 5 arguments, and first is the input 0, and second one is origin. No, second one is not origin, second one is string value, that is polyline. Now the first point, which is origin, and the next point is scattered points. So it will take 4 arguments. So it will take 4 arguments. Okay, and now we have this, is lines which are going outwards with different radius values, and then we can work on them in the way we like. Okay, so this is a lot hard coded, but we can make it dynamic, adding some more values. But I just wanted, in this example, I just wanted to give you the benefit of adding this fit function. Okay, so in this video that is enough. Thank you very much.